A windshield is an important part of a race car, especially for land speed racing streamliners. It needs to fit into the aerodynamic shape of the car, it needs to hold its shape and be shatter resistant, and you have to be able to see out of it. These are actually competing requirements in some ways because an aerodynamic shape will often leave you with a windscreen that is raked so far back that you can't see through it, and the compound curves of a slippery surface can make everything look like a funhouse mirror. A possible solution to this problem, and the one I chose, is to run lots of analyses and get a good shape, and then form your own windshield into this shape using a fiberglass wrapped mold and a homemade oven in your garden. And it's not as difficult as it sounds. It's much more difficult. Every time that I have been involved in an event that became a news story, I read the news later and I thought, that's kind of what happened. The facts are there, but the story seems slanted. If you want to know what really happens in the news, you need to be part of every event that becomes a news story. Or just check out Ground News. Ground News gathers related articles from news sources around the world and gives you context about the sources of that information, their political bias, the reliability of their reporting, who owns them, all backed by 3 independent news monitoring organizations. Ground News will show you if you're only getting one side of the story, it will show you how a story is being reported across the political spectrum, and it will show you how many sources are reporting on a particular story. Take a look at this story on an F-16 flying with the help of artificial intelligence. You can see that there are 73 news sources from across the spectrum. The bias distribution chart shows that 20% of sources are reporting on the left, 66% in the center, and just 14% on the right. With one click, you can see the bias comparison and see how different sides are reporting on the same story. For instance, you can see that the right is emphasizing DARPA's involvement in evaluating AI against human pilots, which seems significant for the future of combat, and it's interesting that the left and center are not focusing on this. The algorithm has fighter jets now. The slant that each news source has becomes apparent when you can compare the same story across different outlets. Go to ground.news/Superfast Matt to give it a try. If you sign up through my link, you'll get 40% off the Vantage plan, which is what I use to get unlimited access to all the features. Ground News has changed the way I read the news and is doing important work. Click on that link and take advantage of 40% off. Polycarbonate, often referred to by the trade name Lexan, is a shatter-resistant clear plastic. It's required for windshields in many racing series. There are a few different ways to make a polycarbonate windshield. The easiest approach, and the one most teams take, is to cut out a flat pattern and just kind of bend it around the body of the car. You can do this on a hot day by screwing down one side and just sort of slowly bending it around, adding screws as you go. It wants to spring back flat, but if your canopy is rigid enough, it doesn't matter. If you want a compound curve, which I do, you need to heat up the windshield and form it on a mold. More complex shapes will use a vacuum mold or a 2-piece mold to pull the polycarbonate down into the shape, but with a relatively basic shape like mine, you can do what's called drape forming. Drape forming is pretty simple. You heat up an oven to about 370 degrees Fahrenheit, stick your blank in there for about 20 minutes, then you pull it out, set it on the mold where it will drape like a cloth onto the mold and take that shape. A few minutes later, it's cooled off and you have a new windscreen. The only 2 complicated parts are that you need a mold and you need a pretty big oven. We'll start with the mold. If you watched my previous video, you know that I've been making molds for the fiberglass body that will go on the car. I did this using polystyrene insulating foam from the hardware store. We're going to do the same thing for the fiberglass mold. To get the design, I started with the canopy. I extended the top up here because I want to drape the windshield in a larger piece. If you flatten out the windshield, it becomes a U shape, which could be a problem. If we drape it onto the mold in its final shape, the corners might sag down. So we're just going to keep the top part continuous and trim that off later. I made this in 4 layers, the top, the bottom, and the 2 middle layers, which is where the final windshield part will be. Doing it this way allowed me to trace out the shape of the final windshield onto the mold along the layer lines. Since my CNC is only 3 axis, it's really hard to get a feature line cut into the foam on all the sides to show me where to place and trim the windshield. So we used a Sharpie. The problem with using polystyrene foam for this is that it melts relatively low. So if we take out the hot polycarbonate and lay it on, it will just melt the mold. We can solve this problem by coating the mold in a thin layer of fiberglass, 2 layers actually. By the way, you have to use epoxy resin on this stuff. If you use polyester resin, it'll just eat away the foam. I did have to compensate for this in the mold. The final surface is the outside of the windshield, minus the thickness of the windshield, minus the thickness of the cotton that I'll talk about in a moment, and minus the thickness of the fiberglass shell. We finished the fiberglass layup with some peel ply on top to make sure we had a nice surface finish and let it cure. And then the satisfying peeling of the peel ply. Oh yeah. Unfortunately, we got some dry spots where the foam absorbed the resin, but we patched those with some 2-part filler I had lying around. It's not exactly the right stuff, but it's probably fine. For some reason that I don't fully understand, you're not supposed to put the polycarbonate directly on the mold. You're supposed to use a sheet of flocked cotton or flocked rubber. I got some cotton and spray adhesived it onto the mold. We roughly traced out the outline of the final windshield so we would know where to place the Lexan when it comes out of the oven. And just like that, we had a mold. I have an oven that does not get very much use. Unfortunately, it is not large enough for a windshield. This means that we will need to make a larger oven. For this, we need a heating element, a temperature sensor, some temperature controls, a fan, and an insulated box. The hardest part of this is the fan, believe it or not. We need this thing to be nearly 400 degrees Fahrenheit, and electric motors don't like to work at that temperature, mostly because magnets stop being magnets at about 200 degrees. So we'll need to have a motor with a long shaft and the fan on the inside of the oven with the motor on the outside, which is actually exactly how household ovens solve this problem. In fact, a household oven solves all of my problems except the large insulated box. So I checked Facebook Marketplace and bought the cheapest oven I could find. $70. Not bad. As for the big insulated box, we will make it out of foam, not that pink foam I was using. As I said, it melts at a much lower temperature than we need. For this, we will use polyisocyanurate, henceforth referred to as shiny foam. I drew up a CAD model of the big foam box and adjusted the dimensions until it was large enough, and also only used 2 4x8 sheets of shiny foam. We got the 2-inch thick kind and cut it into all its constituent pieces. I got some high-temp tape for this, and we taped up all the inside seams and all the outside seams and made a big box. Now, here's the deal. I really don't want this oven in my garage for 2 reasons. One, there's probably going to be a lot of nasty fumes coming off this thing, either from the polycarbonate or the polyisocyanur whatever. And 2, there is a non-zero chance that this contraption will burn down my entire house. What I lack in workshop space, I make up for in garden space, and since I currently want an oven more than I want this rosebush, we'll put it right here. We were originally going to set the whole thing up here on this ledge, but then we decided to just have the oven on the ledge and have the foam box in front of it on some sawhorses. So we killed a plant for no reason. The problem with this setup is that the fan in the oven is designed to circulate air around the oven and not an extra large shiny foam appendage strapped to the front of the oven. It's a centrifugal fan pulling in the air in the front and blasting it out the perimeter. The heating coil is behind this metal here. There is another heating coil on the top for roasting and broiling. I bought a 4-inch metal duct and a flange to attach this duct to the face here with some stainless steel tie wire. Ideally, I could blow air through this duct to the other side of the foam box, but since this is a centrifugal fan, it doesn't work backward. It only sucks. We tied it to the roof with some of that tie wire and offset it to one side, hopefully resulting in clockwise circulation of air in the giant foam box. To test this, I bought 4 of the cheapest probe thermometers I could find and shoved them in 4 different places on the foam box. Unfortunately, even with the fan and duct, we were seeing 30 degrees difference in the thermometers from the front to the back. So we had to do one of 2 things. We could turbocharge the oven fan by removing the motor and replacing it with a much bigger motor, or we could turbocharge the oven by adding a turbocharger to it. I know this sounds ridiculous. This is exactly the type of thing that people do just for the clicks on YouTube, but this actually makes perfect sense. I need to move hot air around an oven, and I don't want to spend any more money, and I have this turbo lying around, and a vacuum, and it even has a wastegate so we can regulate flow. Therefore, I have a way to move hot air around the oven for no money. Actually, I bought this tube here to direct the air for $6, so for a little bit of money. And yes, I would be lying if I said I did this solely for practical reasons. My oven has turbo spool, and that is hilarious. But it is kind of the most practical solution, which makes it even more awesome. The turbo is ball bearing, so I wasn't too worried about it not having a constant supply of pressurized oil, but I did 3D print a hopper to drip oil in slowly. I also printed an adapter to hook up my vacuum. I swapped the vacuum hose to output so it would blow air instead of sucking it in. About this time, I decided to check the accuracy of the temperature probes I bought by sticking them in some boiling water, and they were all pretty bad. They disagreed by as much as 30 degrees, which was actually how much the front of the oven was lower by, so it turns out we didn't actually need to turbocharge the oven. I just needed to buy decent thermometers. But I'm sure each of you have all unnecessarily turbocharged the windshield forming oven that you built in your garden, so maybe don't be so judgmental. We wrote corrections on the thermometers, but from here on out, we mostly just trusted the thermocouple. For some reason, it is super difficult to find software that will give you a good flat pattern from CAD, so we just got some tracing paper and traced out the flat pattern from the mold. Then I cut out the proto windshields from the Lexan. I did manage to get 4 of them out of one 4x8 sheet with a couple of inches extra on the sides. I got the orientation right by taking a picture of the traced out windshield and tracing it again in CAD with some pertinent dimensions. You know what actually would have been easier? Just to get Send Cut Send to cut me out some windshield templates, but whatever. The thing about Lexan is that it absorbs moisture from the air. It's not usually a problem until you heat it up and then it gets little bubbles in it. To prevent this, you have to heat it up to about 250 degrees for about 6 hours, longer for thicker sheets. This lets all the water evaporate out so you can heat it up to 370 degrees without it bubbling. I always like to do my own testing to find out how important things like this actually are, so we threw a piece of scrap Lexan in at 400 degrees and baked the moisture just to see what happens. And yeah, you definitely need to dehydrate it first. So 6 hours in the oven at 250, we laid down some of that flocked cotton on the oven floor so it wouldn't stick to the shiny foam. Then we kicked the oven up to about 370 degrees. The thing with home ovens is that most of them are not great at keeping a specific temperature. They fluctuate up and down a lot. You can fix this with a PID controller, which keeps the temperature in a more tight range. PID stands for Proportional Integral Derivative, which are the 3 ways the controller calculates a correction based on the measured temperature and the target temperature. I bought one of these controllers, but I didn't actually install it. We just took the temperature probe out of the oven and put it in the foam box, and we just kind of moved it in and out to maintain the proper temperature. This is also PID control. It's the programmable intern Dave. And the box actually kept a pretty consistent temperature, in part due to the rapid circulation of air thanks to the turbocharger. We did need to put the oven on roast so that it would use both heater coils, and since the top heater coil doesn't have a fan, the turbo was helpful in getting the heat around the box. So we needed the turbo in the end anyway. After 16 minutes at 370 degrees, we opened the foam box and pulled out the Lexan. Unfortunately, the green cotton sheet stuck to it, so it took us a moment to get it off and get the part on the mold. Within 10 seconds, we had it on the mold. Unfortunately, the stuff cools off really fast, like faster than 10 seconds, especially where we picked it up. This part was warped from where we grabbed it. We were going to trim this part off anyway, and overall the shape was pretty close. If this was all about shape, we could probably make this thing work. Unfortunately, you need to see out of a windshield, and it was all funhouse mirror. It was bad. We had lines running along the bends, we had some of that green cloth stuck to it, and there were small bubbles. It was not great. There's not a whole lot to see out on the salt flats, but you do need to see the things that are out there. Cones and mile markers, they are important, and unfortunately, this windshield is not going to work. It's hard to know exactly what went wrong with the first windshield since I have exactly 0 experience in this kind of thing prior to this first semi-failure, but we can deduce a few things from this result. The tiny bubbles probably mean that we didn't bake off the water for long enough. This oven is not really made for drying, so it probably needs a little extra time. The lines along the curvature make it seem like maybe the top cooled before the bottom, or maybe it just wasn't quite hot enough. And the bits of green fabric tell me that it probably doesn't need to be sitting on the fabric inside the oven. We thought about doing a test with a smaller piece, but we had 4 windshield blanks, so we just went for it. This time drying for 8 hours, baking a little hotter around 390, and we just put the Lexan right on the shiny foam. We also marked center lines on the mold so we could get it more quickly positioned. And this time it was better. Kind of better. Just barely better. Fewer lines, no bubbles, but still not a great windshield. We busted out the heat gun and tried to make it a little bit flatter and a little smoother, but it did not help. It actually kind of made it worse. Videos like this are build diaries, but I like to wrap them up into a how-to so people doing similar things can learn from them. And some of you will point out that I have not conveyed a successful way to make a polycarbonate windshield. And that is because this is not a video on how to make a windshield, but a video on how to turbocharge your oven. The polycarbonate windshield video comes later, after I figure out how to make a polycarbonate windshield. I do have 2 more blanks, but the difficulty of this path is becoming clear, a lot more clear than my windshields. And yes, I am on track to spend more money making this windshield than I would have had I just paid somebody else to form it in the first place. But you forget, we do not do these projects because they are less expensive. We do them because we are not smart enough to know that they won't be less expensive. This is a lesson that I will never learn. So, you have learned nothing worthwhile, and I have accomplished nothing, and we have all wasted 15 minutes. That's not true, I wasted a week and a half. But maybe in the end, the real windshield is the friends whose time we wasted along the way. The problem with this approach is that I forgot my lifelong axiom that all of life's problems can be solved with laser-cut parts. I wanted to get fancy with this because the CFD analysis said I could get an extra 3 miles per hour with a formed compound curve windshield rather than the simple curve. I was hoping to get 2 or preferably 3 of these made because some of the teams I talk to go through about 1 windshield per season because of scratching or cracking or whatever, and I think it's probably worth finding an easier and more repeatable way to make a windshield. I probably don't want to build a garden oven once every 2 seasons. So I redrew the canopy and ordered a new windscreen blank from my friends over at Send Cut Send, but that will have to wait for a later video because I am busy making the body. I will also talk about the specifics of this in a later video, but I wanted to talk about something now, and that is stickers. I haven't put much thought into what color I want to paint the car, but in my mind it's always been white for no particular reason, but you can't have a white car. It has to have a color that contrasts with the white salt flats because they want to be able to see you when you crash and explode. Anyway, I'm going to paint it white, but we're going to make it a mostly different color by putting stickers all over it. And this is where you come in. Send me a sticker and I will put it on the car. Any sticker. Doesn't matter what it is. As long as it fits flat in an envelope, I will put it on the car no matter what. Is this going to negatively affect the aerodynamics of the car? Probably. But this way, if I don't break the record, it's your fault. If you don't have a sticker, but you have a good idea for one and also say $18, then good news. I will print out your sticker for you, put it on my car, and I'll send you one of mine. The link is below. This is a fundraiser to help pay for the body since all this stuff is getting really expensive. Keep in mind that I get to decide where on the car your sticker goes, so before you upload that image or slide that sticker into an envelope, consult this handy guide to give you an idea of what to send. Also, I do accept bribes, so send bribes. Thanks for watching.